Article 210 in the 1999 National Electrical Code covers the sizing of wires. According to the 1999 NEC, the following color coding is required for 220-volt loads. Refer to section 210.5. Hot wires, also known as ungrounded conductors, should be either black or red. The neutral wire, also known as the grounded conductor, should be white. The equipment grounding wire should be green or bare copper. If you ran a black, white, and green wire in 3/4-inch polyvinyl chloride conduit, and the inspector directed you to change the white wire to black, it is likely that your circuit is a 220-volt circuit. For specific guidance, consult section 210.5 of the 1999 NEC to determine the appropriate wire size for your 220-volt load. The wire size needed will depend on the amperage of the load and the length of the wire run. Understanding wire sizing involves several key factors. Firstly, you need to determine the load requirements. Calculate the total amperage that the circuit will need to carry. This is crucial for selecting the correct wire size. Secondly, consider the ampacity of the wire. Ampacity refers to the current carrying capacity of a conductor. The 1999 NEC provides tables that list the ampacity of various wire sizes based on their insulation type and installation method. These tables are located in Article 310 of the NEC. For example, Table 310.16 lists the allowable ampacities of insulated conductors rated up to 600 volts, not more than 3 conductors in a raceway or cable or earth, based on ambient temperature. Thirdly, account for voltage drop. Voltage drop is the decrease in voltage along a conductor due to its impedance. Excessive voltage drop can cause appliances to malfunction and reduce the efficiency of the electrical system. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, use the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is the direct current constant, approximately 12.9 ohms for copper and 21.2 ohms for aluminum. I is the current in amps, D is the one-way distance in feet, and circular mils is the cross-sectional area of the conductor. Fourthly, consider the type of insulation. The insulation type of the wire affects its ampacity rating and its suitability for different environments. Common insulation types include THHN, THWN, and XHHW. Each insulation type has different temperature ratings and resistance to moisture and chemicals. Fifthly, choose the correct conduit size. The conduit size must be large enough to accommodate the wires without overcrowding. Overcrowding can lead to overheating and damage to the wires. The NEC specifies the maximum number of conductors allowed in different sizes of conduit. This information can be found in Chapter 9, Table 1 of the NEC. Sixthly, adhere to the color code requirements. Proper color coding is essential for safety and for identifying the purpose of each wire. As previously mentioned, black or red wires are used for hot conductors, white wires are used for neutral conductors, and green or bare copper wires are used for grounding conductors. The inspector's instruction to change the white wire to black indicates that the white wire was being used as an ungrounded conductor in a 220-volt circuit, which is not permitted by the NEC unless it is permanently re-identified at both terminations. Re-identification typically involves wrapping the wire with black electrical tape or using a black marker to indicate that it is being used as a hot conductor. Seventhly, ensure proper grounding. Grounding is a critical safety measure that helps to protect against electrical shock. The grounding system must be properly installed and connected to a grounding electrode, such as a ground rod or a metal water pipe. The size of the grounding conductor is determined by the size of the service entrance conductors. Information on grounding can be found in Article 250 of the NEC. Eighthly, use appropriate connectors and terminations. Use connectors and terminations that are rated for the wire size and type being used. Ensure that all connections are tight and secure to prevent overheating and arcing. Ninthly, follow all applicable codes and regulations. Electrical work must comply with the NEC and any local codes and regulations. It is important to consult with a qualified electrician or electrical inspector to ensure that all work is performed safely and in accordance with the applicable codes. 10thly, consider future expansion. When sizing wires, it is advisable to consider future expansion or increased load requirements. It may be prudent to install larger wires than currently needed to accommodate future needs. In summary, determining the appropriate wire size for a 220-volt load involves considering the load requirements, ampacity, voltage drop, insulation type, conduit size, color code requirements, grounding, connectors and terminations, applicable codes and regulations, and future expansion. Consulting Section 210.5 and other relevant articles in the 1999 NEC is essential for ensuring that the electrical installation is safe and compliant. Additionally, remember that electrical codes and regulations can vary by location. Even though you are referencing the 1999 NEC, local amendments or state-specific regulations may apply. Always check with your local electrical inspector to confirm the specific requirements in your area. Furthermore, consider the specific application of the 220-volt circuit. Is it for a specific appliance, such as an air conditioner, water heater, or electric range? Each type of appliance may have specific wiring requirements that need to be considered. For example, some appliances may require a dedicated circuit with a specific wire size and overcurrent protection. The manufacturer's instructions for the appliance should provide guidance on the wiring requirements. If the 220-volt circuit is serving multiple loads, it is important to calculate the total load and size the wires accordingly. The NEC provides guidelines for calculating the demand load for various types of occupancies and appliances. Using these guidelines can help ensure that the wires are adequately sized to handle the expected load. Remember that the information provided is based on the 1999 National Electrical Code. Newer versions of the NEC have been published since then, and they may contain updated requirements or changes to the color code. It is always recommended to consult the latest edition of the NEC and any applicable local codes and regulations to ensure compliance. In addition to the points mentioned above, consider the importance of proper labeling. Clearly label all circuit breakers and wiring connections to indicate the purpose of each circuit. This can help prevent confusion and make it easier to troubleshoot problems in the future. Use a permanent marker or label maker to create clear and legible labels. Also, ensure that all electrical panels and junction boxes are properly identified with appropriate warning labels. These labels should indicate the voltage of the system and any potential hazards. Proper labeling is essential for safety and for preventing accidental contact with live electrical parts. When working with electrical wiring, always follow safe work practices. Turn off the power to the circuit before working on any wiring connections. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. Never work on electrical wiring while standing in water or on a wet surface. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to perform the work. Attempting to perform electrical work without the necessary knowledge and experience can be dangerous and can result in serious injury or property damage. To further elaborate on the importance of ampacity, consider the impact of ambient temperature. The ampacity of a conductor is affected by the ambient temperature in which it is installed. Higher ambient temperatures can reduce the ampacity of a conductor, as the conductor is less able to dissipate heat. The NEC provides correction factors that must be applied to the ampacity ratings of conductors based on the ambient temperature. These correction factors are found in Table 310.16 of the NEC. For example, if a conductor is installed in an ambient temperature of 90 degrees Celsius, the ampacity of the conductor must be reduced by a certain percentage, as specified in the table. Ignoring the impact of ambient temperature can lead to overheating of the conductors and potentially cause a fire. Another factor to consider is the rating of conductors when multiple conductors are installed in a raceway or cable. When multiple current-carrying conductors are installed together, the heat generated by each conductor can raise the temperature of the other conductors, reducing their ampacity. The NEC provides directing factors that must be applied to the ampacity ratings of conductors based on the number of current carrying conductors in a raceway or cable. These directing factors are found in Table 310.15b2 of the NEC. For example, if there are 4 to 6 current carrying conductors in a raceway, the ampacity of each conductor must be reduced by 80%. Failing to direct conductors properly can lead to overheating and potential fire hazards. In addition to the NEC, there may be other applicable standards and regulations that need to be considered. For example, Underwriters Laboratories all publishes standards for electrical products and equipment. UL listing indicates that a product has been tested and meets certain safety requirements. When selecting electrical products, it is important to choose products that are UL listed or certified by another recognized testing laboratory. Also, be aware of any state or local regulations that may apply to electrical work. Some states or localities may have more stringent requirements than the NEC. It is important to check with the local authorities to ensure compliance with all applicable regulations. When installing electrical wiring in a building, it is important to consider the type of construction. Different types of construction may have different requirements for wiring methods and materials. For example, fire-rated construction may require the use of specific types of conduit and wiring that are designed to resist the spread of fire. The NEC provides guidelines for wiring in different types of construction in Chapter 3. It is important to consult these guidelines to ensure that the wiring installation meets the requirements for the type of construction. Furthermore, think about the importance of surge protection. Power surges can damage sensitive electronic equipment such as computers, televisions, and appliances. Surge protection devices, SPDs, can help to protect against power surges by diverting excess voltage to ground. SPD should be installed at the service entrance and at branch circuits to provide comprehensive surge protection. The NEC provides requirements for the installation of SPD in Article 280 and Article 285. Consider the use of arc fault circuit interrupters (ASICs). ASICs are circuit breakers that are designed to detect arc faults, which are a common cause of electrical fires. ASICs can detect arc faults before they start a fire and trip the circuit breaker to de-energize the circuit. The NEC requires the use of ASICs in certain locations, such as bedrooms and other areas where arc faults are more likely to occur. Also, be aware of the requirements for ground fault circuit interrupters, GFCIs. GFCIs are designed to protect against ground faults, which can cause electrical shock. GFCIs detect ground faults and trip the circuit breaker to de-energize the circuit. The NEC requires the use of GFCIs in certain locations, such as bathrooms, kitchens, and outdoor areas where there is a risk of exposure to water. When installing electrical wiring outdoors, it is important to use wiring and equipment that are rated for outdoor use. Outdoor wiring and equipment must be resistant to moisture, sunlight, and other environmental factors. The NEC provides guidelines for outdoor wiring in Article 300. It is important to follow these guidelines to ensure that the wiring installation is safe and reliable. In addition to the technical aspects of wire sizing and color coding, it is important to consider the ethical responsibilities of electrical work. Electrical work should be performed with integrity and professionalism. It is important to be honest and transparent with clients and to provide them with accurate information about the electrical system. Electrical work should always be performed in accordance with the applicable codes and regulations, and safety should always be the top priority. By adhering to these ethical principles, electricians can build trust with their clients and contribute to the safety of the community. Remember that electrical work is a critical trade that requires specialized knowledge and skills. It is important to stay up to date on the latest codes and regulations and to continue to learn and improve your skills throughout your career. By investing in your education and training, you can provide high-quality electrical services and ensure the safety of the people you serve.